Welcome to Hope Academy. My name is Mr. O, and this is another part of the FASTREV videos. Today, I'm going to be going over specific sample means or general population testing, hypothesis testing for this. I'll explain to you how you are able to identify that this is specifically going to be for this case, that it's going to be a z-test for this question, along with how to go about doing the hypothesis testing specifically for this type of question. And so I'm going to read you the question and go ahead and get started on this. So the question states this: in 1960, census results indicated that the age at which American men first married had a mean of 23.3 years. It is widely suspected that young men today are waiting longer to get married. We plan to test our hypothesis by selecting a random sample of 20 men who married for the first time last year. The men in our sample married at an average age of 24.2 years with a standard deviation of 5.1 years. At alpha equals to 5%. Is there enough evidence to reject this belief? Okay, so the first thing I noticed right off was that they told me this. They stated that the census result from 1960 resulted with a mean of 23.3 years. That is my population value. So usually, if they explicitly tell you something like that, and that like sort of value that's separate from like you sampled a group or whatever not, that is going to represent my population. The next thing that tells me that this is going to be a hypothesis test based on means and not something based on proportions is the fact that they give me a mean value. Another hint is the fact that if I continue reading this, they do mention the random sample of 20 men, but they give me an average, aka a mean value of 24.2 as my sample value with a standard deviation value. This is hints that this is not going to be a proportion test question, or proportion values question. The main reason why is because usually they don't give you a standard deviation value explicitly, or they don't exactly tell you there's an average or a mean value of some sort. Usually, if they give you that explicitly, this is going to be a mean question or something based on population-based testing. And so I'm going to go ahead and get started on the test. So step one. Step one, as I mentioned in the various videos before, but I'll repeat myself, is that the step one will always be the null hypothesis and alternative hypothesis. Null hypothesis meaning that it's going to be a value that's just equals to, nothing that changed, it's just very true to the true population value, while the alternative is what we're trying to prove. Okay, so my null hypothesis for this question states it's going to be my mean value. So right now, my V value, they mentioned right here, is 23.3 years. That is the population value, the true value, the true value of this question. And so that is going to be my value for the null hypothesis. My alternative hypothesis is what we're trying to prove. And it states that we believe that it actually increased, that more men are marrying later on. So that means my mean actually has to be greater than 23.3. And so if I then mean, I could define mean as the true mean of the true mean of the year, the age at which, and I'm going to copy this word, which American men first married. And that concludes my first step. So I usually could define it. It's not necessary, but it's just something, just to be safe, to ensure that you get full points on the AP statistics exam. Second step. My second step for this question will always be my conditions, as in what rules do we have to abide to for this specific mean question. Well, for this question, usually we always have to mention that there is a sort of a random sample, SRS. So simple random sample means that it's just a random selection of whoever it is. And it actually mentions right here, a random sample of 20 men. So I am good. Also usually just mention independent as usual. It's just an assumption that we make, because especially since we did a random sample, we could assume that each variable that's involved will be independent from one another, so that one man I select will not affect the result of the next man I sample when it comes to their average age. And so another thing I need to mention is the normalcy, that is normal. And because we have a population value, it doesn't really mention too much that this is going to be a normal value or that the distribution of this or the how we sampled it is going to be normal, but we usually assume that if it's not mentioned otherwise. If it does mention in the question that this population is not normal, we have to end the test here and we cannot test it anymore. But since they never mentioned anything of that sort, we could assume that this is going to be a normal population. And that concludes my step 2. Step 3 is my computation to find the z value for this. Okay, and so when I'm looking for the z value, I always have to remember this is always going to be my observation minus mean over standard deviation. Okay, and my mean for this question, aka mean, and I'll write it in parentheses, is going to be 23.3 because that's what I'm testing for. My observation for this question is going to be what the sample value was provided, which is 24.2. And my standard deviation, and I do want to remind you about standard deviation specifically towards means or general population values, is going to be my population, or aka my population standard deviation over square root n. Okay, and that's going to what that's going to mean is that for this question right here, it's provided right here that it's a 5.1. So specifically the standard deviation is 5.1 over square root of the sample, which is 20. Okay, and so on the calculator, I'm going to type that down. 5.1 divided by square root 20. Whoops. And I get 1.1404 because I'm rounding up a little bit. 1.404. Okay? And so I'm going to go ahead and get started on this. So C equals to 24.2 minus 23.3 over 1.1404. Okay? And on the calculator, be aware there is rounding off going on here. It's just very important for us to be aware of that. So it's not going to be the exact perfect value, but it's near enough that we could work with it. 1.1404, and I get a z value of 0.7892 because I'm rounding off. Okay, so that is step 3. Step 4 is me converting this to a p-value because, as I mentioned before in the other videos, but in case this is your first time watching this type of video, the important thing is that I need to make it into a value that I can understand. Right now, it's in the z value, and what this exactly means is that it's 0.7892 standard deviations away from the mean in a normal curve. So if I had a normal curve right here, and this was my mean value, this is going to be the space that it exists. 0.7892 is the space or amount of standard deviations away from the mean. And that helps, but then it doesn't really tell me much about whether or not what my probability is relative to that. And so I'm going to go ahead and convert it. So my probability of z being greater because, aka this is what I was testing before, z, going up or higher than 0.7892, and this is how I'm going to solve it. So I'm going to go ahead and test it out and solve it out. The way you go about doing so is that I'm going to push second distribution. I'm going to go to number 2, normal CDF. And because it's greater than, I'm going to first type 0.7892 comma 999. And I'm going to go ahead and write this down on the paper too just to show you. And I get 0.215 basically. Okay? And so that's my p-value. The way I was able to compute this is first, as I mentioned before, I pushed second on the calculator. I went to vars, clicked vars, and then I clicked number 2, which will say normal CDF, parentheses, right? So I'm going to show it one more time. Second vars, go down to number 2, enter. The reason why afterwards, on the normal vars, I actually wrote 0.7892, and I should scribble this out, comma 999, was because the question is asking me to go on the right-hand value for this question. So that means that when I'm doing this test right here, I need to make sure to test the right-hand side. And the procedure for that is I first put the z-score value right here, and then afterwards put 999. And that's where I got 0.215. And so now step 5. Step 5 is my conclusion. And what does this 0.215 means? That means that there's a 21.5% chance of this occurring, that people are actually older than what the average is. And now we're going to state that this is not the case, that is not significant, because 0.215 is not lower than what we are trying to prove. It's not lower than at 0.05 or 5%. If it was lower than, we can reject null hypothesis, but because we are not lower than, we fail to reject null hypothesis. And that is what I'm going to write. Since the p-value, and I'm going to write p-value, which is 0.215, it's greater than the alpha, which is going to be at the 0.05, we fail to reject the null hypothesis, H0, or you can write null hypothesis. Thus, and I'm going to follow the wording right here that's up here. I'm just going to copy down the wording. Thus, we cannot state that that young people today are waiting longer to get married. And that concludes my explanation for step 5, and that concludes how I was able to solve this out. Now I'm going to go ahead and show on the calculator how to go about doing this, and then conclude this video for today. And so this is how I went about doing so. So if you want to double check, make sure that your computation is correct and whatever not, how you're going to go about doing this is you're going to push stat right here. You see this button right here, stat. And I'm going to click the arrow key once to test. Afterwards, there is a z test value right here that I could do it. And then when you go to this calculator right here, it's going to be set up like this. It's going to look like with the data chart with whatever not. But this is not what I need, because the only time I'll use the data chart thing is if I was actually given like specifically the 10 people or the 20 people and their ages all listed in like a chart format in which I have to input into a list, which is another whole lesson in itself. But I'm going to switch it to stats because this is a stats-based question. Right here, my true value of mean is going to be 23.3. I'm following the question. And I'm going to bring this down just in case you want to follow along. My standard deviation for this question is going to be 5.1. My sample, aka my actually sample mean, aka, is going to be 24.2, or observation value, and my sample is going to be 20. And I'm going to change this to greater than, because that's what our null hypothesis states. It's going to be greater than, and I'm going to calculate it. Right here, because a round off error is very feasible, it is a bit large, but there is a decent amount of round off error that's occurring. But right here, it states that my p-value is going to be around like 17%, which is possible as a round off occurrence. And that still tells me that we failed to reject the null hypothesis. And thus, you could check just to confirm whether or not your work is correct. Make sure the more accurate you are, the better it is. And so you can see right here that there is some round off errors that did come out along the way. But it is about right what I did my computation to this. And that concludes my explanation for today. Thank you so much for watching. Please do leave comments below if there are any concepts or mathematical or statistical concepts that you want me to cover. I'll do my best to do so. Please do like our Facebook page and subscribe to our YouTube channel so that I can continue to make good content like this. And I hope you have a wonderful day.